Okay, so we're going to change this equation into vertex form. Now, I think initially you're just like looking at this saying, there's no way I'm going to do this. Well, it's probably because you're thinking, well, vertex form, I have to do it that same old way of completing the squares. But no, 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 no. We've got to remember there's multiple ways of doing everything. So instead of using the completing the squares process, let's find the axis of symmetry, because we know that the x value of the vertex is the axis of symmetry. So you have to recall that the axis of symmetry equation is x equals negative b divided by 2a. So now we just have to substitute those values into these letters. And so negative b is negative 3/2 divided by 2 times a is negative 1/2. Okay, so we see that 2 times negative 1/2 is just a negative 1. So this really ends up being, well, let me go a little slower. It's negative 3/2 divided by negative 1, which just means that x equals 3/2. So that's our x value at our vertex. Because remember, we have a quadratic. A quadratic is in the shape of a parabola, and actually this one's going to be upside down because it's negative, so it's in the shape of a parabola, and the vertex is right here, and the axis of symmetry is the line that goes right straight through the vertex. So if the axis of symmetry is x equals 3/2, then that means this x value is 3/2. Well, once we know that, we can quickly solve for the y value, because we just have to find out what the value of y is when x equals 3/2. So we're going to input 3/2 into our function. So our function is negative 1/2, and we're going to input 3/2 in for our x squared, because we're still just rewriting that function, plus 3/2 times 3/2, because we're putting 3/2 in for x, minus 2. Okay, so we have to use PEMDAS and do our exponents first. So 3/2 squared is just 9/4, because we just squared the 3, we squared the 2. So we have negative 1/2 times 9/4 plus, now when we're multiplying fractions together, we multiply the numerators, multiply the denominators, so we get 9/4 minus 2. Okay, so just like I said before, when we have, now we're dealing with this one right here, and these two fractions here, when we multiply fractions together, we multiply the numerators together and the denominators together. So when we do that, we're going to get negative 9/8 plus, and we need to change this fraction so that it has an 8 in the denominator, so that we have common denominators. So that's just, it takes 2 times 4 gets us 8. So we're also going to multiply 9 times 2, so we have 18/8, so that we can now combine those two fractions. And we also have to convert negative 2 into a fraction so that it has a denominator of 8. And so in order to get the understood one denominator there to be an 8, we multiplied it by 8. So 2 times 8 is just 16. And we recognize that 16/8 is equal to 2. So we're all set now. Now that we have all of our fractions with a common denominator, we can simply just combine the numerators. So we have negative 9 plus 18 gives us 9, positive 9. Positive 9 minus 16 gives us negative 7. And so we have negative 7/8. So our vertex is now 3/2 comma negative 7/8. Well, how does that help us in creating the vertex form? Well, you remember we just have to, the vertex form is a times x minus h all squared plus k. Well, this is h and this is k. So let's write that form right quick. So here's our vertex form, and so we're just going to substitute our values in. Now, a comes from the original equation, and the original equation tells us that a is negative 1/2. So we have f of x equals negative 1/2 x minus our 3/2 from our vertex, all squared, plus our k, actually I'm not even going to write that plus because it's a negative 7/8. And there's our vertex form of that equation that looked like it was going to be really hard to write. Actually, that doesn't look like a 7, does it? It looks more like a 1. So let's fix that. And so there we go. So that is another way of getting our vertex form if it looks too complicated to do the completing the squares option.